let us see the next topic of D and F block elements of transition elements from complexes. Why they form a complexes? Transition elements have variety of properties. In the introduction itself we saw it form colored salt, it has a variable oxidation states, and it forms complexes, it forms alloys and act as a catalytic activity. Then it has a colored forms due to the unpaired electrons, paramagnetic character, magnetic movement. So lot of properties, and that one of the property is formation of complexes due to three reasons. One is very small size of the atom or ion and very high positive nuclear charge and presence of vacant n-1d orbital with appropriate energy to accept the lone pair of electrons donated by the Ligands. Then it forms a complexes. Complexes means already I said in our coordination lesson, that is central metal ion will accept the lone pair of electrons from the Ligands. It forms complexes. So it donates the lone pair electrons by Ligands are called as a Louis base, accept the lone pair of electrons are called as a Louis acid. So central metal atom accept the lone pair of electrons, so it acts as a Louis acid, and Ligands are donating the lone pair of electron to the central metal atom. They formed as called as a Louis base, so they form a complexes. So due to small size of the atom or ion or high positive charge and the nuclear charge and presence of vacant n-1d orbitals with appropriate energy, it accepts lone pair of electrons by the Ligands. So Ligands are donating. So transition metals form complexes, molecules with carbonyl, CO, NO nitrosyl, NH3 amine, H2O aqua, and F minus fluorido, Cl minus chlorido, Cn minus cyanido, Kc. So these are the Ligands name. Already I explained in coordination compound lesson. These molecules combine with the central metal and form a complex. For example, Fe2 plus adding 6 cyanido negative Ligands, you are getting complex Cn minus enclosed in close bracket and central metal ion and square bracket above the charges 4 minus. So there is a rule. First rule, we should say the number. Second is say the name of the Ligand. And third rule is say the name of the central metal atom or ion. And then it followed by the oxidation state of central metal ion to be enclosed in the closed bracket. So we should follow the 4 rule. For example, it is 6 and this is 4 minus difference 2. So oxidation state of ion is plus 2. It is one of the shortcut method to find out the oxidation state. So 2 plus to be written in a Roman letters. So now the first rule is number is 6, so X. Then Ligand name is cyanido Kc. Then central metal ion is called, it is a anionic complex. So we should say the central metal ion should say in a Latin word of special name ferrate. So anionic complex means central metal ion to be ended with ate. So it is ferrate Roman letter 2. It is ionic complex, so it is a ion to be ended by ion. So cyanido Kc ferrate Roman letter 2 ion. So this is a complex formed by the Ligands. These are the types of Ligands, and with this up to water, it is all neutral Ligands. Carbonyl is a neutral Ligand, nitrosyl is a neutral Ligand, amine is a neutral Ligand, aqua is a neutral Ligand. Fluorido is a negative Ligand, chlorido is a negative Ligand, cyanido, Kc is the negative Ligand. To this central metal ion, that cyanido is a combine and form of complexes. This is the definition of the transition metals form complexes with the 3 reason and example hexacyanide. So let us see another example. Example of transition metal complexes. This is all cationic this 3 plus is cationic complex, and this is Cu NH3,4SO4. It is a neutral Ligand, a neutral complex, and this is anionic complex, and this is anion, and this is neutral. So for example, ferrous cyanide with actually FeCN2, only suppose it is FeCN2, it is 4KCN, it forms a FeCN2 dot 4KCN gives K4 FeCN6. So ferrous cyanide, FeCN2 is called as a ferrous cyanide reacted with the 4 molecules of potassium cyanide, and just remove this plus and write FeCN twice dot 4KCN, or we can write in complex formation potassium 4 potassium outside and inside central metal ion connected with the 6 Ligands. So potassium, first name potassium, then number hexa, cyanido, Kc, ferrate, Roman letter 2. It is a anionic complex, so it is a ferrate 2. So Gopal 3 plus is reacted with the 6 NH3. It forms CONH3 6 times the whole power 3 plus, chromium 3 plus with the 6 H2O, chromium 6 times aqua, the whole power 3 minus. So here this is 6. So hexa, amine, Gopal, Roman letter 3 ion. So 6 aqua, hexa, aqua, chromium, Roman letter 3 ion. So this is raised to the power of 3 plus. This is cationic complex. This is also cationic complex. These are the simple examples for the formation of transition metal and metals will form coordination complexes. Coordination compounds or coordination complex, both are same. Thanks for watching.